Representation of forces. Representation of forces. How many types of force that is present in the member? There are two types of force that is present in the member. Write down here. Representation of forces. Representation of forces. Representation of forces. Now, in the members, there are two types of force. One is compressional force or tensional force. Tensional force. Now, let us consider, for example, let us consider any member from the plane truss. From the above figure, you consider any one member. So, let us assume this is the member BD. This is the member BD. Now, if the force that is present in the member is compression force, then the arrow mark should be always towards the joint. Towards the joint. So, this will be a compressional force. In the same way, this is the member BD. If the force that is present in the member, if the force that is present in the member is tensional force, then the arrow mark should be away from the joint. See here, the arrow mark is away from the joint, right? So this type of force is tension force. Now, here in the member CD, here both the arrow marks are away from the joint. Then what type of force it is? Tension force. So here in the member DF, the arrow marks are towards the joint. If the arrow marks are towards the joint, then what type force is present in the member DF? That will be a compression force. So in this way, we have to represent the forces that is present in the member. So this is not, this is representation of forces. So this is our representation of forces. Now let us find the member forces that is present in these members. So total how many members are there? Total how many members are there? See here, member 1, member 2, member 3, member 4, 5, 6, 7, 8. So now you have to find the member forces with the help of method of joints. So what type of forces that is present in the member? It may be a compressional force or it may be a tensional force. So total there are 8 members. Total there are 8 members. So you have to find the type of force that is present in the member and along with its magnitude, type of force and its magnitude and its magnitude and its magnitude. Here type of force means either it may be a compressional force or it may be a tensional force. Magnitude means what amount of force that is present in the member. So here now we have to calculate the member forces for each member, right? So now let us start finding the member forces. Let us start finding the member forces. So here consider joint A. Consider joint A. So start with the joint A. We know that here the value of RA is 1000 Newton. The value of RA is 1000 Newton. Value of RF how much? Value of RF is equal to 1000 Newton and HF is 0. HF is 0, right? HF is 0. So draw the free body diagram at joint A. This is the joint A. To the joint A, you have to draw the free body diagram. So to the joint A, how many forces or reactions are acting and the how many members are connected. So here to the joint A, there are two members connected. To the joint A, two members are connected and there is a one reaction which is acting vertically upward. One reaction which is acting vertically upward, and its magnitude is 1000 Newton, and its magnitude is 1000 Newton. So here, what is the value of theta? Theta, find the value of theta here. This theta value. How to find this theta value? So tan theta is equal to tan theta is equal to opposite. Tan theta is equal to, this is the opposite and this is the adjacent, right? So opposite by adjacent, 3 divided by 3 is equal to 1. Theta is equal to 45 degree. So you got the value of theta, that is 45 degree, and you have to find the forces that is present in the member AB and AC. Now how to find the member forces? So here you don't know, these are the unknown forces. Name them. This is FAB, FAB, and this member force is FAC. FAC. So here you don't know the force that is present in the member. So always keep in mind, if the force that is present in the member is unknown, then you have to assume that the force that is present in the member is tension. Tension means the arrow mark should be away from the joint. The arrow mark should be away from the joint. If the arrow mark is away from the joint, then the force that is present in the member is tension. So you are assuming, wherever there is a unknown members, then you have to assume that the force that is present in the member is tension. In the tension, in case of tension, the arrow mark should be away from the joint. So here, with the help of these two equations, summation of horizontal force is equal to 0, comma, summation of vertical force is equal to 0. So with the help of these two equations, we will going to find the value of FAB, FAB and FAB and FAC. FAC, right? So here, first start with, always start with summation of horizontal force is equal to 0. How many horizontal forces are there at the joint A? So one is FAC. This will become plus because the force is acting towards the right. Rightwards means the force is moving from the left to the right. Next one is inclined force. This inclined force, after resolving, this will become FAB cos 45 degree. FAB cos 45 degree is equal to 0. So here there are two unknowns. FAC, here FAC is unknown, plus FAB. FAB cos 45 degree, this is also unknown, is equal to 0. So in this case, keep as it is the equation 1. Next, summation of vertical force is equal to 0. Summation of vertical force is equal to 0. Now, how many vertical forces are acting at the joint A? So here we can see that one is 1000 Newton, 1000 Newton, 1000 Newton plus here 1000 Newton plus FAB, FAB plus, because both the forces are acting towards upward direction. So FAB sine of 45 degree, FAB sine of 45 degree is equal to 0. So both are positive. Now there is only one unknown force, right? So in this case, you can find the value of FAB. FAB is equal to minus 1000 Newton divided by sine of 45 degree. Sine of 45 degree is equal to minus 1414.21, right? Minus 1414.2, minus 1414.214, minus 1414.214. 214 Newton. So you got the value of FAB. FAB is minus 1414.214. Here minus indicates the assumed direction is wrong. What you assumed was tension, but it is not a tension, because if negative sign indicates the force that is present in the member is compression. So this is compression. Minus means compression. Now substitute this value in the equation 1. So substitute this value in the equation 1. Here you substitute. So here you will get FAC plus in bracket minus 1414.214 cos of 45 degree. Cos of 45 degree is equal to 0. Then you will get FAC value. What you will get? FAC value 1000 Newton. So here this is positive. So the assumed direction is correct. So the force that is present in the member is tension. The force that is present in the member is tension. The force that is present in the member is tension. So here you got the member forces in the member FAB and in the member FAC. So FAB, what type of force that is present in the member FAB? That is compression force, right? That is compression force. Compression force means the arrow mark should be towards the joint. The arrow mark should be towards the joint. That is 1414.214 Newton. Now, what type of force that is present in the member AC? That is tension. Tension means the arrow mark should be away from the joint. The arrow mark should be away from the joint, and the force is 1000 Newton. So in this way, with the help of joint A, we have determined the value of force in the member FAB and force in the member FAC. Now consider joint B. Consider joint B and find the member forces that is connected with the joint B. Right? So now let us consider joint B. So here, by considering joint A, you got the force in the member, that is FAB and FAC. Now consider joint B. Consider joint B. Consider joint B. Draw the free body diagram. Draw the free body diagram at joint B. This is the joint B. Now draw the free body diagram. So here, to the joint B, how many members are connected? To the joint B, there are total 3 members. To the joint B, total 3 members are connected. One is horizontal, vertical, the another member is inclined. So here, to the joint B, this member is FBD. FBD, name of this member. Name of this member is FBC. FBC, the force that is present in the member here is 1414.214 Newton, and here you can see here the force that is present in the member is compression. In the force in the member AB, compression force is present, so the arrow mark should be towards the joint. So these forces are unknown forces. We have to determine these forces that is present in the member FBD and FBC. So if the member forces are unknown, then we have to assume that the force that is present in the member is tension. You have to assume that the force that is present in the member is tension. So FBC, FBD. Here the force that is present in the member FBA is compression, and its magnitude is 1414.214. This is Newton. 214 Newton. 214 Newton. 214 Newton. So let us start finding the forces that is present in the member. So summation of H is equal to 0. Summation of H is equal to 0. This is 45 degree, because already we know that this value is 45 degree. For right angle triangle, this angle always 90 degree. So Here it will be 45 degree. So total it will be 180 degree, right? 90 plus 90, 180 degrees. So this will be a 45 degree. How many horizontal forces are there? Here one force FBD. FBD is a horizontal force because it is moving towards right plus. Again, here there is one compressional force. The arrow mark is towards the joint. The arrow mark is towards the joint. So 1414.214 Newton. So here after resolving towards horizontal, this will become sine of 45 degree. Sine of 45 degree is equal to 0. So FBD is equal to minus 1000 Newton. FBD is equal to minus 1000 Newton. So you got the value of FBD. Now summing of all the vertical force is equal to 0. Summing of all the vertical force is equal to 0. So how many vertical forces are there? Two vertical force. One is FBC and the other one is inclined force 1414.24. Here FBC is acting towards down. If the force is acting towards down means it will be minus FBC plus 1414.214. This will be cos because the vertical force is resigned towards the theta. So cos of 45 degree is equal to 0. FBC. FBC is equal to 1000 Newton. Now you got the value of FBC and you got the value of FBD. Because it is a negative, the assumed direction is wrong. The force that is present in the member is compressional force. Here because it is plus, so the type of force that is present in the member FBC is tension. FBC is tension. So in this way you got the value of a force in the member, that is FBD and FBC. Now again substitute. Now again you substitute FBD plus and FBC minus. So FBD plus FBD is minus. See here minus compression. Compression means the arrow mark should be towards the joint. The arrow mark should be towards the joint. So 1000 Newton. Here FBC is tension. Tension means the arrow mark should be away from the joint. The arrow mark should be away from the joint. So 1000 Newton. 1000 Newton. So in this way we got the type of force and its magnitude that is present in the member FBD and FBC. So here by considering joint A, you got the force in the member FAB and FAC, and by considering joint B, you got the force in the member present, that is in the force in the member FBD and FBC. In the similar manner, consider 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 joint consider joint C. Consider joint C. Draw the free body diagram. Draw the free body diagram to the joint C. Draw the free body diagram for the joint C. So this is the joint C. How many members are connected to the joint C? How many members are connected to the joint C? This is the joint C. So here to the joint C, one force is acting towards the down. One force is acting towards the down, that is 1000 Newton. That is 1000 Newton. And associated with the joint C, there are total 4 members are connected. One member force is F FCE FCE, and the other force is F sorry FCA FCA, and the force that is present in the member is 1000 Newton tension force. 1000 Newton tension force. Here there are two members are connected. One is tension force. So tension means the arrow mark should be away. So the force that is present in this member FCB. FCB is 1000 Newton, 1000 Newton, and there is one inclined force. and there is one inclined force. So the name of this member is FCD. FCD, right? So here the force that is present in the member FCE and FCD, FCD, FCE and FCE is unknown, right? You don't know the value of the force that is present in the member FCD and FCE. So here the arrow mark should be away from the joint. The arrow mark should be away from the joint. So you are considering that the force that is present in the member FCD is tension and the force that is present in the member FCE is tension. Here the angle is 45 degree. Here the angle is 45 degree. Now consider joint D. After considering joint C, so summing of all the horizontal force is equal to 0. Summing of all the horizontal force is equal to 0. So here total how many horizontal forces are there? 1, 2, 3. One is minus 1000 Newton because the force is acting towards left. The other one is plus FCE and here FCD was 45 degree plus FCD cos of 45 degree is equal to 0. So here total two unknown forces are there. Two unknown forces are there. So it is not possible to find the forces in the member. So keep as it is and name it as equation 1. Name it as equation 1. Now summation of vertical force is equal to 0. How many vertical forces are there? Total 1, 2 and 1 inclined force, that is plus 1000 plus 1000. This one is minus 1000 plus FCD for sine of 45 degree. FCD sine of 45 degree is equal to 0. So you'll get FCD is equal to 0. This value will get cancelled. So FCD is equal to 0. Now substitute this value in equation 1. Then you will get minus 1000 minus 1000 minus 1000 plus minus 1000 plus FCE plus 0 is equal to 0. So FCE is equal to 1000. FCE is equal to 1000 Newton. FCE is equal to 1000 Newton and FCD is equal to 0, right? FCD is 0, FCD is 0 and FCE is 1000 Newton because here this is positive. This is positive. The assumed direction is right and the force that is present in the member is tension. FCE is tension force. So the arrow marks should be away from the joint. 1000. Here this is 0. The force that is present in the member FCD is 0. Just write in here it as a 0. So in this form, with the help of joint A, you got the force in the member FAB and FAC. With the help of joint B, you got the force in the member FBD and FBC. With considering the joint C, you got the force in the member FCD and FCE. So in the similar manner, you can find the forces that is present in the other members. Just follow the same procedure. You can find the forces in the member easily.